So here we have the system of equations in P and G, where P represents the peaches in pounds and G represents the grapefruits in pounds, and we have to solve for P and G. So we can solve the system of equations either by substitution method or by elimination method. I'm going to use the substitution method. So for that, I'm going to solve for P from the first equation. So therefore, P equals, we have to subtract G from both sides. We get 2.5 minus of G. Otherwise, we expressed P in terms of G. Now we take this expression for P and replace it into the second equation. That is, in place of P, we replace it as 2.5 minus G. So when we do that, we get 1.58 times of 2.5 minus G plus 1.09 G. This equals 3.46. We distribute this 1.5 into the terms inside the brackets. That is 1.58 times of 2.5. When we multiply this, we get 3.95. And then 1.58 times of negative g, that is negative 1.58 g. We then have this 1.09 g. This equals 3.46. So we can combine this like term 1.58 g plus 1.09 g. And when we do that, we have this 3.95. So this becomes 3.95 minus of 0.49 G. This equals 3.46. We then subtract 3.95 from both sides. So we get negative 0.49 G. This equals 3.46 minus 3.95. And this equals, that is 3.46 minus 3.95 equals negative 0.49. So therefore, we have the equation negative 0.49 G. This equals negative 0.49, which means we can now solve for G by dividing both sides by negative 0.49. So we do that, that is negative 0.49 divided by negative 0.49. So here we get, these two gets cancelled. We have G equals, so this goes 1 times equals 1. So we found the value of G equals 1. Now we can determine the value of P. We take this value of G and substitute into this equation for P. So therefore we will get P equals 2.5 minus G equal to 1. So therefore this becomes P equal to 1. So we found the values of P and G, and therefore we can say that the person buys P pounds of peaches. That is P is, I'm sorry, this P is 1.5, because 2.5 minus 1 is 1.5. So we say that the person buys 1.5 pounds of peaches and 1 pound of grapefruits. And that answers this question.